Hello, in this video I want to talk about the maze generation used in the game My Poor Retinas. So this was developed for a Bridget Riley inspired take on the classic Berzerk. So as you can see here, as we move around, the level is actually changing. So the mazes here are always completable, but they're always different. However, if you go back to a previous one, its layout is actually always consistent. So I'm going to take a look at how I did that and also how sorted out making the setup actually work. So let's take a look at this from the scene view. So here's what the level actually is looking like. We're using a terrain here, and the terrain is getting procedurally generated. These walls that get added in and the drops off on the side are generated in code. Now what you'll notice is actually the texture here. If you're familiar with the Unity terrain system, you'll notice that the texture here is not actually behaving the way that it probably does if you're using the default setup. In that with this, we can actually visibly see that from the top-down point of view, it looks like these sections, the texture is being more compressed. Now, if we look at it from here, we can see that actually the texture isn't being compressed. Quite specifically, the texture is not getting stretched here. But because when we look at it from an orthographic point of view, it looks stretched, that creates the effect we wanted. Now, this is actually not the default behavior. If I come in and I actually change the terrain so it's actually using a different shader, so if I switch it to using the default, then it's actually quite hard to see these sections. Now we can see the lighting on them, so we can see that they're shaded differently, but we don't actually get that distortion effect which we're aiming for as part of the effect for the game, because Bridget Riley's artwork features optical illusions. It features distortions in sort of these fairly standard patterns. So this is actually done using a shader. This isn't one that I developed myself. This shader is one that's part of an asset pack. So this is part of an asset pack from Raving Bots. That's a terrain triplanar shader. And so what happens with this triplanar shader is, so normally with the standard shader on terrain, the UV coordinates, so the coordinates used to map out textures, are projected top down. So these points here, the UV coordinate is calculated purely based upon their position horizontally and vertically, so their position in X and Z. Doesn't take into account the actual slope. What a triplanar shader does is the triplanar shader actually takes into account the normal of the surface, and it uses that in order to determine what the actual texture should be at any particular point. So this was an asset from the asset store. Was ridiculously simple to integrate. It was a case of add the asset, drop it in, done. So I do recommend taking a look at that. It was far easier than writing the shader myself because I'm not particularly familiar with shaders. But how is this actual maze being generated? And how am I guaranteeing that the maze is always solvable? So if we take a look at the code for this, so the way this is actually working, it's using the same process that the original game did, largely. So the way the original game worked is you had these pillars, and you had 4 columns and 2 rows of the pillars, which these points here, we've got 4 across and 2 down. So we've got 8 pillars there between all of the sections for the maze. So that gets used. So we know our pillars, but how do we work out which one goes which direction? So the process, and this is using the algorithm that the original Berzerk game did. So I keep track of what X and Y coordinate I am for the map, and that's just handled as a fairly simple, straightforward coordinate. If you go up and leave the map from the north side, then it increases the Y. If you left the map from the eastern side, it would increase the X. And conversely, leaving south decreases Y, leaving west decreases X. and it uses that x and y coordinate as the seed for the random number generator. That's how it ensures that you can go back to a previous one and it looks the same. Then what it does is it goes through for each pillar, and each pillar it randomly picks a direction. Now, because of the organization of the map, this is guaranteed. It will always be solvable. Because even if all of the pillars went towards one side, there's always going to be a gap here. It's actually not possible for this to generate a maze where you can't exit from. You could conceivably get a section where the center part here was all fully cut off, but because the player always enters from the sides, the player is always still going to be able to progress. So we pick a random direction, and then based upon that, we actually control the dimensions. So I created a pillar class, and you give it your location, and you also give it the dimensions of that pillar, so the width and length of it. So we've got that set up. We're creating our actual pillars. Then from our terrain, we grab our height map, and then we loop through that height map. And for each location, we calculate what influence a pillar has, which we get that from the actual pillars themselves. So what they're doing, so they're keeping track of their locations, and they're keeping track of their bounds. The way they work out their influence at a point is, okay, we look and see if the pillar is one that's going north and south. If it is, then our influence is calculated based upon the horizontal distance. If we're going east or west, then our influence is calculated based on the vertical distance. This is so that we get that effect of the... I could actually have used both the distance in x and y, and that would have allowed me to give a, I guess, sort of more smooth, rounded appearance to the pillars, but I quite specifically wanted to have that very angular shape to them. Now, this influence only applies if we're actually within the area for the pillar. Outside of that, it's going to be 0, and we just calculate the influence along that main axis. Now, what we do is, because multiple pillars might be influencing the same point, we just use the maximum. I could average this, potentially, but I think using the maximum also works okay. Maybe the average might give a slightly smoother response. I'm also then taking into account for borders. So this ends up being a little bit tricky in that we've got for the left border, we have for the right border, and I'm realizing now I could have just used else ifs for this. It would have made it a little bit more efficient, probably should have. And then I'm also checking to see for adding in these sections, for adding in these exit portals, because these, the terrain doesn't actually fall off. So how I handle that is if I'm within those exit sections, then I force the influence to 0. And I do similar for vertical, and then that determines my influence. And then it's quite a straightforward process that because the height map goes from 0 to 1, 1 is maximum height, 0 is minimum height. As the influence increases, we decrease the height. Now, if I wanted this more rounded, then I potentially could have used an exponential here, but in this case, a simple linear worked effectively. So once I've set all the heights, then I just apply that into the height map, and then I'm done. As we move, we keep track of whether we're moving north, south, east, or west, and that updates the direction. And I ensure that it's always between 1 and 256. And then that gives me this effect here, where I'm able to move around, the mazes are reproducible, and they're always solvable. And as I said, I didn't reinvent the wheel here, I'm just reusing the same process the original game did. I just had to tweak it for being able to actually manipulate the height map for the terrain. If you have any questions, then please leave a comment below. I hope you've enjoyed the video. Until next time, bye.